Hello guys, today I want to cover this problem. This problem is from last year's AP Calc BC exam. It's from section 2 part B, and let's look at this problem. So part A asks us about approximation of the double derivative, and we are given the derivatives of this graph, this function, right? So what we need is to differentiate the derivatives, and what we can do, they said us to use average rate of change. So it's basically the derivative of r if t is equal to 10 minus the derivative of r when t is equal to 7 divided by 10 minus 7. And when we plug in these numbers, we will get gonna be plus divided by 3, and it's just minus 0.2. They also ask for units. So the units of the derivative is centimeters per day, but we are calculating a derivative, so it would be centimeters per day, and this is double derivative, so it's per day again, or centimeters by day squared. You can say like this. Part B asks us if there are any t from 0 to 3 of which is equal to 6, right? And we can see that the derivative of this function, right, which is equal to minus 6, lies between the derivative at t equals 0 and t equal to 3. And because we can twice differentiate this function, it means that it's continuous, and it also means that we can differentiate it at once, and our function, and it means we can differentiate it once. We can use intermediate value theorem that says that there must exist point if the function is continuous for which this holds, right? And t is from 0 to 3. This thing is 6.1 and this thing is 5. So there must exist point for which is true. And for the next part, we need to calculate Riemann sum. So basically, what the Riemann sum is, let's sketch a graph. For example, ln of x. So looks like this. And basically, we need to divide x-axis to equal segments and just calculate each rectangle, the area of each rectangle. And in our case, it's basically we need to calculate for intervals which were given, and also it's important to use the last value in the interval. So in our case it's 3 minus 0, because right we have there 3 and there is 0 times minus 5 because it's the value of the derivative of r of t if t is equal to 3. And we will do the same thing. Let's calculate. So this is minus 15. This is 4 times 4.4, it's 17.6. This is 3 times 3.8, it's minus 11.4. And this is 2 times 3.5, it's minus 7. This is 29. So we will get minus 51. And for the last part, we need to find rate of change of the volume. So we need to differentiate the volume, which is v equal 1 over 3 pr squared h. And of course, r is a variable and h is a variable. So if we want to differentiate with respect to t, we need to use a product rule. So dv by dt is equal to, we'll use implicit differentiation, right? So it's 2/3 drh times dr over dt plus 1/3 br squared times dh by dt. So let's just write our values. R is equal to 100, h is equal to 50, dh by dt is equal to minus 2 because it decreases, right? And dr by dt is equal to minus 5. And we just need to plug in those numbers. So it's 2 over 3 pi times 50 times minus 5 plus 1/3 pi by 100 squared times minus 2. This is minus 50,000 pi over 3, and this is 20,000 pi over 3. So in total, it's minus 70,000 pi divided by 3, and this is our final answer. I hope you enjoyed this video. Leave your thoughts on this problem in the comments. Thanks for watching and see you